How can Hubble see distant galaxies clearly, but not Pluto? Hubble has taken some of the most breathtaking images of space that we know of, giving us clear views of galaxies millions of light years away. And yet, it struggles to take clear images of celestial bodies much closer to us like Pluto and other trans-Neptunian objects. Surely that doesn't make sense. How can it see something so clearly so far away? And yet, the most detailed view of Pluto is this. The answer is a lot simpler than you may think. It's all about the angular diameter of the object in question. This fantastic image is of the Andromeda galaxy, a galaxy found roughly 2 million light years away from us. You might think that this distance would make it relatively small from our perspective, but even though it is so far away, use a high exposure camera and you'll find that it is actually 6 times bigger than the Sun, or a full moon in our sky. This is because it is big, 220,000 light years across, and at that size, 2 million light years away from us is not enough to make it seem tiny. Its size and distance from us mean that it covers 3 degrees across the night sky. It is so big, in fact, that when Hubble looked at it, it couldn't see the whole thing in one go. It simply couldn't zoom out enough. So, this image is actually a mosaic of hundreds of Hubble exposures. And even then, they couldn't fit the whole galaxy in at once. This is true of other galaxies as well. Now, most galaxies aren't as close or as big as Andromeda, but they are still big enough for Hubble to image them and see interesting details while it's at it. Here's the Pinwheel Galaxy, 21 million light years away. Now notice how it covers the gap between some foreground stars found in our galaxy. That's to give you some idea of how big it is in the sky. If you could see it clearly with your naked eye, it would appear just smaller than the moon. I hope this gives you some perspective. Even though it is so far away, it is huge, and so it still has a large apparent size in our sky. As you can imagine, this makes it much easier to imagine. Just as a side note, I can only imagine how beautiful it would be if all galaxies local to us were bright enough to be visible to the naked eye. But what about Pluto? We might need to clarify our measurements. To describe the size of something in the sky, astronomers use degrees, arc minutes, and arc seconds. 60 arc minutes in a degree, and 60 arc seconds in an arc minute. So Andromeda was 3 degrees across, and the Moon is about 30 arc minutes across. The Pinwheel Galaxy is about 28 arc minutes across. Pluto is a minute 0.11 arc seconds away at its closest approach to us. That makes it ridiculously small in our night sky. It is a wonder that Hubble can resolve any details on it at all. But again, closer and larger planets, which have bigger apparent sizes, can be resolved more easily by Hubble. That's why sending New Horizons to Pluto back in 2015 was so exciting. We really didn't know what to expect before we got there, as we don't have a telescope powerful enough to resolve any details on Pluto, and so everything New Horizons sent back was a revelation. Here's one last example from right here on Earth to really hit the idea home. In this picture, you can see objects at various distances and sizes. I want you to think of this flower as Pluto. It's small and blurry at this distance, and yet there's some buildings in the background much further away than the flower, which are clear in this image. Imagine that these are the Hubble images of galaxies. So that should clear up the mystery of our first question. On to number 2. Why do Pluto and its big moon Charon orbit around a point in empty space? Not all of you would know that Pluto was doing this, but those who had heard of it might have reason to wonder. Is there something invisible and hugely dense there? Perhaps some kind of tiny, lurking black hole. As the New Horizons probe approached Pluto and Charon in 2015, it saw this orbiting phenomenon up close and in detail. But in reality, no black hole explanation is necessary. Scientists were expecting this before New Horizons even arrived, even though they had never detected anything present at that point. This is because everything in space, not just Pluto, orbits around a barycenter. A barycenter is the center of mass between two objects. To help visualize this, if I get a nice butternut squash on one end of a stick and a kiwi on the other end, we can see that the center of mass is more towards the butternut. For most of the planets, with their much greater mass than the moons orbiting them, the center of mass in these situations resides within the planet itself, meaning it wobbles as its moon's gravity tugs on it. With Pluto and Charon, though, they are much more similar in mass, which means the point in which they orbit is outside of Pluto, making it appear like they are swinging around an invisible object in space. The only other place that this happens with all the other big celestial objects in the solar system is, surprisingly, the Sun and Jupiter. So, another enigma about Pluto was solved. Now, what about number 3? A lot of you have asked, how are the New Horizons images of Pluto so bright, seeing as Pluto is so far away from the Sun? Surely Pluto would be pitch black in reality, right? Well, the answer is, with your naked eye, if you were to look at Pluto, it would indeed be darker than in these images, but interestingly, not as dark as you may suspect. Thankfully, we don't have to try and imagine it, because twice a day on Earth, at dawn and dusk, the illumination of our sky matches how bright Pluto can get at its high noon. NASA calls this Pluto time, and you can check this website out to find out when it will happen next where you are. As you can see, it's Pluto time here, and my mobile phone camera can still easily take a video. Pluto is an average of 40 times further away from the Sun than the Earth, and only has 16% of the sunlight. Direct sunlight on Earth is 100,000 lumens per square meter, so on Pluto it would be around 60, the equivalent to indoor stairway or corridor lighting. Even if that level was a problem for our cameras, we can still see darker objects by utilizing longer exposure times. Here's the nighttime where I am, and with a 15-second exposure, my camera can pick up a lot of details. And if it still appears dark, I can always raise the brightness afterwards in some editing software. So, there you go. Why does Pluto appear so bright in New Horizons photos? We've got one last question to go, and I think this may be the biggest question the general public asks about Pluto. It is part a search for an answer, part a cry at the injustice of it all, but its answer actually comes with some fascinating nuance. It is of course this: why is Pluto not a planet anymore? Before I explain, did you know that we were once considered to have 100 planets in our solar system? It's true. Throughout the ages, the number of planets in our solar system has gone up and down quite a lot. And no, before you ask, this is not because planets suddenly appeared and disappeared, but rather due to how they were discovered. Since antiquity, there have been 5 planets beyond Earth, which are the ones visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. The ancient Greeks added the Sun and the Moon to their list of planets, but that idea never really caught on. In the late 1700s, Uranus was discovered, which was revolutionary at the time, as no one considered there could be more planets beyond the visible 5. After this discovery, more and more planet candidates were being found, like Ceres, Vesta, Pallas, and Juno, which are all found in what we now know as the asteroid belt, or the large belt of asteroids between the orbits of Mars and Jupiter. But these were not initially listed as asteroids. In science textbooks in the early 1800s, they were all listed as planets. In the middle of the 1800s, Neptune was also discovered, and within just a few decades, we had quite a list of planets on our hands. There just wasn't a clear distinction between the 8 planets we know today and the large asteroids that were being discovered. By the 1860s, over 100 asteroids had been found, and they were finally given their own distinct classification as asteroids. Asteroids were described as objects that couldn't be distinguished from stars, bar the fact that they move across the sky. So you might as well ask why Pallas isn't considered a planet or demand justice for Juno. A lot of people in the world feel like Pluto has been hard done by, but Pluto was just another victim of this ruthless refinement of categorization. In 1930, Pluto was discovered, and with the excitement of finding something so large and distant, it was classified as a planet. However, within a few decades, it was discovered that it didn't follow the conventions of traditional planets. The planets we know have circular orbits that align roughly with the plane of the solar system. Pluto, on the other hand, orbits at an angle to the solar system, and its orbit is so elliptical that at some points during its year, it's closer to the Sun than Neptune. But it was also unique, so no one minded it being called a planet. But then, in the 1970s, Pluto was discovered to be a lot tinier than expected. It turned out that its mass is only 1/6 of that of our Moon. This made things a little awkward. Why call Pluto a planet, but not our Moon when it was so much bigger than Pluto? Trouble continued for Pluto in the 1990s, when telescopic technology had greatly increased, and other worlds were being discovered in and around the orbit of Pluto. Just like the discovery of the asteroid belt, it quickly became apparent that there was another belt beyond the orbit of Neptune, now known as the Kuiper belt. These objects are still being discovered, the most famous being Eris, Sedna, Haumea, and Makemake. But seriously, they have found a lot. Just look at this list. In 2006, the International Astronomical Union knew that something had to be done. It was time to come up with a new definition for the word planet. They finally classified a planet as a celestial body that A. is in orbit around the Sun, B. has sufficient mass for its self-gravity to overcome rigid body forces so that it assumes a hydrostatic equilibrium, nearly round shape, and C. has cleared the neighborhood around its orbit. So, although Pluto fits the bill for the first two categories, because it lies in the Kuiper belt, it has not cleared its orbit and thus is not a planet. I have heard arguments that lots of planets actually have many asteroids in their orbits too, but it is a bit different to have some asteroids around you. Compared to being in an actual belt, Pluto is instead known as a dwarf planet, which is almost the same, except it's not massive enough to have cleared its orbit. We shouldn't see this as a slight against Pluto, but rather because of these new discoveries, we have a whole new category of celestial objects to learn about. Also, because of the classification change, there is a silver lining for the once planet Ceres. It got promoted from being an asteroid to becoming a dwarf planet. So, better than nothing. So there you have it. 4 questions about Pluto were solved, but how many more questions have now arisen? Perhaps as you've watched the icy beauty of Pluto and learned of its mysteries, all that's happened is that it's got your mind turning in even more directions, like the mythical Hydra. Maybe this is a beast that can never truly be slain by just chopping off its heads. But that's part of the beauty of the universe. We can learn so much, and there is still so much more to learn. It's the journey that is most satisfying. If watching this video has sparked in your mind any more questions about Pluto, its motions and characteristics, or our solar system in general, let me know in the comments below.